After we looked at a quick summary of the explanatory regression modeling, we are moving into a quick comparison between data mining and statistics. And the following quick summary is based on what Hans published in 1998. A lot more came into the domain of data mining after 1998. However, the general concept of the comparison stay hold. So, if you want to look at the main differences uh, between those two domains, let us talk about what those domains focus on. So, data mining in general is known that is not only works with numerical or categorical types of data, but also data mining is very powerful in heterogeneous type of data, such as you will hear pattern recognitions in images using data mining algorithms, video analysis, text, we talked about that, like Twitter, Facebook, and signal analysis. Those are big domains where you can apply data mining, where the statistical analysis limited to be able to come up with solutions in this type of heterogeneous type of data. Also, data mining assumes that the raw data that you bring into the model, it's not of sufficient quality to apply a selected statistical methodology directly. Instead, the data must be prepared with appropriate pre-processing techniques, and that was our beginning of the CRISP model. We said the data will start first. We know that the data doesn't have a high quality, a lot of missing data, a lot of noisy or sparse data, very known term. For example, the clickstream data that you get from the web most of the time will be a matrices with a sparse information, which means you will get an attribute maybe one or two times someone clicked on it, where the rest nobody clicked on. So it's really sparse data that you need to handle with data mining. So also they will tell you that between 70 to 80% of your work is in data mining is in preparing your data and making your data clean, transformed to apply data mining algorithms on it. What else? Data mining uses flexible predictive techniques that is based on a very strong algorithms, but it has weaker formal statistical justifications. So some algorithms that statistical researchers always criticized for the lack of the statistical justification, such as artificial neural network and decision rules, those are not favorable by the statisticians, but they are very favorable to be used by the data mining researchers. So what else? Sometimes in data mining, and we witness that, you have some hidden intermediate variables that you don't see them behind the scene, and they really influence the output of your model. And if you try it on your own to use what is called the neural network, you will see that more evident. A lot of black boxes that you cannot see what's happening, but they are contributing to the output of your model or to the efficiency of your model. Now, what data mining is trying, or the goal of any data mining model, is to find not only the general or the global model based on the data that you are dealing with, also is trying to find some type of local patterns, what is called local models. Especially when you have a huge space of data, you cannot really generalize, and that's very problematic to be able to come up with a generalized model. You can in some cases where the data are not big or sparse. However, in some special cases, you are trying to look into a very local situation, local modeling or patterns in your model. What else? Data mining is strongly emphasized on the algorithmic approach and pays attention to issue of scalability, because as you know, when you have a heterogeneous type of data where maybe your data set has images, has text, has numerical values, has maybe signals in that data or charts in that data, it's very difficult for you not to be paying attention to the scalability of your model. The model is going to be really big, and the data you're dealing with is so huge. So you will have to find an efficiency type of analysis to be able to handle this large data sets. Okay. What else? Data mining concentrate on data management and optimization of the data. That's really important. So when we looked at the GRASS model, we focus on the problem by starting with looking at the pre-processing of the data. Then we looked at how to clean the data. Then we looked at the algorithms and the data structure on hand. However, in statistics, it's more oriented to formalism of final model representation. So as you saw in the previous quick summary of how to create explanatory statistically based linear regression, we focus on the formula, we focus on the equation that we generated, and then we focus on the inference that we make from that equation, how much the value of increase of one variable will affect the mean of your function of your y, and that kind of inferences that are the domain of the statistics. Another aspect that is really important to consider is the fitness and the quality of the data. So in order to analyze data statistically, you must first be in a format, the data must be in a format where you can analyze it, okay, and must be organized in a way that you can understand it. However, with data mining, you will see most of the time that the concept of trial and errors is the way that you can handle the data and try to solve a complex problem and to find a better representation of the data. So for example, poor quality data can cause more immediate harm and have other more indirect effect for the data. Okay, so statisticians must consider the state of the data and the applicability of these statistical models. However, working with complex data provide tremendous opportunity for statisticians who master the techniques of data mining. So it's good to know your statistical foundations very well. At the same time, you have to handle problems when you have big data, and you have to understand how to apply data mining algorithms to those two data. So the output of this video is to show you that each one of those two domains has his or its foundation and the reasoning behind it. And you as a data analyst you should learn how to deal with the data based on the business problem on hand. So if you have a problem where the focus is to create explanatory analysis, so go for it with your statistical foundation and come up with that formal description of linear regression model or multiple regression model to come up with some inference about your data. However, if your problem is to come up with a predictive model or to find a clustering solution to unsupervised learning situation, data mining is a solution. So there is no good model or bad model. All what we are saying here is there are different techniques to be used in each of those two domains. So in the case of the data mining, we're gonna introduce what is called how you can come up with effective model. So in data mining, technically this is what we do. We are going to look at how to partition your data into different data sets, training data sets, testing data sets, and validation sets. And accordingly, you create the data from your training data set, you create your model, from your training data set, you test the model to see how well it is, and then you validate one more time to see if that model is really good to apply new data into it to predict the label of that data. Okay, and that's what is called the supervised learning that we have learned so far, taking away the clustering from the picture. So I'm gonna leave this document for you to read and to really try to spend more time on reading it and digest every aspect of it. It's really good to just get a better understanding of the differences between those two huge domains that affect each one of us. And if you like to do research, you really need to be good on grasping each domain and to follow the formalization of how to come up with a good statistical solution or how to come up with a good data mining model. Okay, that's it for here.